Unitree Robotics has unveiled the GD01, a transformable, amazing mecha-style robot that can switch between bipedal and quadruped movement while carrying a human pilot. Weighing about 500 kilograms with a rider, the machine is designed as a futuristic civilian transport platform and can adapt its posture for stability across rough terrain. A demo showcased stable bipedal walking, the ability to smash over a brick wall, and the ability to hold its own under impact. The robot can also retract its legs, shift its center of gravity, and rapidly transition into a four-legged configuration, enabling it to maintain independent mobility across uneven terrain. And to create such innovative designs, you need the right components. That's why engineers turned to Mouser Electronics. Carlo Gavazzi DPA 3-phase HVAC monitoring relays provide reliable protection and monitoring for critical HVAC system components in demanding environments. The relays are designed for systems using low GWP refrigerants like R32 and R290. Additionally, they help OEMs meet evolving safety and environmental standards. Built with spark-free technology, they eliminate ignition risk and comply with IEC and UL requirements for flammable refrigerants. The relays provide continuous monitoring of phase sequence and phase loss, protecting compressors from grid faults and preventing costly downtime. With sealed outputs and upgrade-ready design, they enable easy integration into existing systems. The Carlo Gavazzi DPA 3-phase HVAC monitoring relays are ideal for heat pumps, chillers, and rooftop HVAC units. Check them out today by visiting Mouser.com or by clicking the link below. What are the similarities and differences in mechanical and solid-state relays? To explain, we present David's Corner.
Thanks, Andy. Solid-state relays. What are they useful for? Well, the idea of a solid-state relay is that it uses transistors to allow the current to flow to the load, instead of using a mechanical switch that opens and closes. This is great in some ways, but it has some disadvantages in others. In a traditional relay, an electromechanical relay, switch contacts open and close. Those switch contacts, when they're closed, have extremely small resistance. That means that a lot of electricity can travel through them without generating much heat. It's really nice for large loads. The only problem is it's mechanical, which means as those switch contacts open and close, it takes some time. If we need something to be able to switch on and off really quickly, that mechanical relay isn't going to work. So we turn to these solid-state relays. Transistors can switch incredibly fast. So when we apply the voltage from a pulsed control system, it can pulse the output, or the current going to the load, very quickly, modulating it, in other words. But since they're transistors, they have a little bit of resistance in those contacts, which means that if we supply a lot of current to the load, they're going to heat up more. If we look at the back of them, they almost always attach a metal pad which can be connected to a heat sink to dissipate some of that heat. You never see that on these mechanical ones. So if we want to switch a really heavy load with lots of current, but slowly, the good old mechanical contact might just be the way to go. But if we need really precise control, switching on and off very quickly, then we're probably going to want to turn to one of these solid-state relays, which can be purchased in either for single-phase loads or DC loads or even three-phase loads as well. They're a great way to be able to modernize a control system and give you much more precise control over how that load responds. Andy, back to you.
Thank you, David. All right, it's time to adjust your knowledge gains in our Smart Bit quiz with our 3 control automation questions. The questions are scored using actuator output percentage, and today we'll be testing your knowledge on PLC basics and ladder logic. Let's begin with our first question worth 25%. In a standard PLC scan cycle, when are outputs updated? Is it A, immediately after each rung executes, or B, after the entire program scan completes? And the answer is B. after the entire program scan completes. Most PLCs use an output image table that updates only after the full logic scan, ensuring deterministic behavior. Okay, let's move on to our next question worth 25%. What happens if the same output coil is used in multiple rungs? Is it A, the first occurrence takes priority, or B, the last evaluated rung determines the final state? And the answer is B. The last evaluated rung determines the final state. PLCs scan top to bottom, so the last write to that coil wins. Okay, let's move on to our final question worth 50%. A normally closed contact in ladder logic is true when A, the reference bit is 0, or B, the reference bit is 1. And the answer is A. The reference bit is 0. Normally, contact instructions evaluate true when the associated bit is off or at 0. Want to try again? Just click the link on your screen and be sure to check out our other Automator's Edge videos for the latest in control automation.